Hello everybody, and welcome back. We're going to be saying goodbye shortly to the 2007 Cayley because we are on the very last question, question number 25. But don't worry, I do have other Cayleys on my channel if you're interested in those. Upcoming will be the 2008. It shouldn't be posted quite yet. And of course, I have other contests, 2007 Fermat, if you're looking for a bit more of a challenge. 2007 Gauss will be up soon for people who want to try written stuff aimed at a grade 10 level. And if you've just found this whole thing a little too hard, go back and try your skills on a Pascal. They're one grade level less, they are a little easier, but it's a great way to build up confidence. So, what have we got here? Question 25. In the diagram, 4 squares of side length 2 are placed inside the corners of a square of side length 6. So the space in between also has a length of 2, is what I'm seeing. Each of the points W, X, Y, and Z is a vertex of one of the smaller squares. Square ABCD can be constructed with sides passing through W, X, Y, and Z. And they're not giving us a whole lot more information other than it can be constructed. So we could have lots of possibilities, I guess. I mean, technically, couldn't A just be where W is and B where X is? I mean, that's a square whose sides technically pass through, and I suppose we could even... They have quite a rotated picture, but we could certainly have it a bit more slanted. So there's lots of possibilities here. What we want to know in this question, out of all these possible ways that we could draw in square ABCD, what is the maximum possible distance we could get between A and P? So P, we notice, is down here in the right corner. A, I guess, would have to either be over here or up here to be as far away as possible. If A were somehow this corner here, which they have labeled B, you know, we can definitely get further things away. Remember, they just say square ABCD can be constructed in here. They don't say A has to be between W and X. Okay? I think we can see by symmetry that if there's an A up here that works, the same A would sort of work down here in some similar position. So what I'm going to do is I'm just going to go based off their picture and put A up here. Alright, so we want the maximum possible distance from A to P. Well, it'd be really nice if I had a formula in some way to calculate the distance from A to P and be able to have that formula vary depending on how I place that ABCD square, ABCD square in there. Okay, so they're talking about maximum possible distance. Our first step should probably be just get some way to express the distance from A to P, and then, you know, tweak it ever so slightly. So I'm going to redraw this picture, but I'm going to try and be as general as possible and try and figure out, well, how can I actually calculate the distance between A and P? And I think I'm going to sort of use a right angle triangle, sort of rise over run thing here. So we'll get big square. And it doesn't have to be a super exact picture. As long as I know what I mean, or as long as you know what you mean, no one's actually going to check about your diagrams. I think I will use a color. We'll use the true red. And I will put my ABCD on a bit of a slant. There we go. That looks fairly evenly placed, so I may want to rethink that, but there we go. So P here, and I guess what we really care about is A here, and W and X, and let's get a color here. AP will be... Oh, I don't want to have to redraw my picture, so let's be very careful when we do this. There we go, right down here to P. Alright. So how are we going to calculate this length? Well, they sort of give us a little bit of an idea, because they label some of these sides here. What I'm going to do is I'm going to label a 2 here, and a 2 here, and a 2 here. A is going to be above X, so we're going to, if I use, I guess, the darker blue, I'm going to drop a right angle here. I don't want it to actually pass through my C point, because otherwise you might get the wrong idea. But I'm going to use a right angle here. And so this is 4 plus some amount, some extra little height that I'm going to call y. So we have 4 plus y, and then we have this extra little bit here, x, so this is 2 plus x. And AP is the hypotenuse of this weird right angle triangle I have. So AP squared is going to be 4 plus y squared plus 2 plus x squared. So now I have a way to calculate the length AP based on my sort of position of A. Okay, we're going to investigate these x's and y's. I think they're linked. But the important thing is now I have an expression. And another thing to note, if I want to maximize AP, AP is maximized when AP squared is maximized. So I just need to make this equation as big as possible, and then square root it at the very end. I feel like some people out there might try and square root this. This is just going to give you more of a headache. Okay? I've been a mathematician for a very long time. I know that working with something that constantly has square roots in it can be a bit of a headache. So if we can, we should try and skip it. Okay? So we've got 4 plus y. So here's my y, my little x. Maybe I should call these P and Q just because we don't have those letters, but we do have x already. So I'll call P. Oh, sorry, this one's P and this one's Q. I'm just changing up the letters just so that it might be easier to follow when I start talking about this thing. Because P is the sort of distance we go left from x, and Q is the distance we go up to A. Now, let's sort of zoom in and focus on this for a second. Because as I say, I think we can relate P and Q in some way. So there's W, there's X, and we sort of get A up here. Let's make him a little more lopsided this time. So we get A up here. And drop this perpendicular down here. Now the distance between W and X is 2. So we go over by P, up by Q. So I guess this distance here is 2 minus P. And then, oh gosh, what can we do here? Well, we're going to have a right angle here because it's a square, but I don't think there's a whole lot else we can say. Now, we've got a whole bunch of right angle triangles in here. I suspect that they're similar. If I put a dot here, then dot plus this check is going to be 90, and that puts a dot here, and then that puts a check here. So, yeah, these are similar triangles. AX, I guess we could call this E. AXE is similar to WAE. Similar to WAE. So what could that do for us? Well, it shows us that P to Q is the same as Q to 2 minus P. Oh yeah, of course, it's the geometric mean. So P over Q has the same ratio as Q over 2 minus P. But now we multiply both sides. We get 2 minus P times P is Q squared. And we get 2P minus P squared is Q squared. So we have that relationship going for us. How does this relate back to AP squared? Well, we'll get 4 plus Q all squared plus 2 plus P all squared. What I'd like to do is be able to sort of reduce this and just get a single quadratic, maybe. A single quadratic, and then because a quadratic equation is represented by a parabola, then if it's a downward-facing parabola, the maximum point will just be up there at the vertex. So I think that might be a plan of attack. The problem is, when I expand 4 plus q squared, I'm going to get a q squared, which I can replace with 2p minus p squared, but I'm also going to get a plain old q, which I guess would have to be replaced with the square root of 2p minus p squared. I don't know if I'm exactly happy with that. Well, let's explore. Maybe there's some other angle I'm missing. I don't know. This definitely gives me a relationship between P and Q, certainly. Nothing is immediately coming to mind, so I guess I'm just gonna plug away. So I'll get 16 plus 8q plus q squared plus 4 plus 4p plus p squared when I expand these out. And q squared, so I'll deal with this q in a moment, but q squared is 2p minus p squared, and I get 4p plus 4p plus p squared. So these two are going to cancel out, and we're going to be left with 6p here. And so this will be 20 plus 6p, and then, well, I guess write 2p minus p squared here. So there's the thing. It's not gonna quite work out to be a parabola, is it? Well, I want to make this as big as possible. Should I instead talk about p and not q squared, maybe? I feel a little stumped here. Well, what if I gave a name to... No, Well, this is a bit of a pickle. So I have a choice here. I'm a little stuck. I have a choice. I can either go back and try something else, which is, always a fine option. Or I can just sort of plug away with this and try and maximize this expression, which might not be the easiest thing to do, but at least I have an expression to work with here. Well, if I rearrange this, I could get p squared is 2p minus q squared. So I'm still, This guy, maybe we leave it as q for a second. I mean, that at least looks a little nicer. The problem is we still have a single variable, so we can't turn it into a parabola, but I guess we couldn't turn it into a parabola anyway because we had square root signs lying around. I feel like of the two of them, q should be made bigger, so that's at least some idea. Is there another piece of information that I should have? Let's go back and look at our picture here. So if I knew the side length of AB is S, then by a whole lot of symmetry, I would know that this length and this length add up to S. But in the absence of knowing what that S is, I don't think I can say anything. Is there perhaps some sort of a simple trick I'm missing? Maybe I can get S in terms of P and Q, but I don't think that's going to... Well, no, obviously I can get S in terms of P and Q by exactly what I just said. This length and this length are going to add up to our side length S. I don't think that's going to be especially helpful. So we've got to maximize 6P plus 8Q. That's the challenge now. Make that as big as possible. Okay, because the 20's fine. The 20's not going anywhere. Well, P over Q, isn't that... Maybe I'm spinning my wheels a little bit, but if we take a closer look... So there's our A, Q, to P. This is 2 minus P. What could we maybe get for some values of P and Q? If P is 1, Q is going to be 1 as well. Alright, because Q squared is 2P minus P squared, and that'd be 2 minus 1. If P is 0, Q is 0. What if P were something like root 2? Then we'd have 2 root 2 minus 2, and then so P would be 2 root 2 minus 1, the square root of that. That's a bit messy, but is that a good Q value? Well, I'll grab my calculator and figure that out. So root 2 minus 1, square root that, and multiply that by square root 2. 0.910. Looks like Q being 1 is really leading the charge here. Is there a way to say that Q would necessarily have to be bigger? Ooh. Okay, let's think about this. Well, no, actually, I was about to say we should use the arithmetic mean, geometric mean. I'm now saying that that's not what I want to do, because that would just make Q bigger. We don't care if Q is as big as possible. We want AP to be as big as possible. And yeah, since we do 8Q, it makes sense to make Q a little bit bigger than P, but not at the sacrifice of a really tiny P that makes this shrink here. I can get 34 as my AP squared. You know, if P is 1 and Q is 1, we've shown that that'll work. What would happen if I had AP squared is 34? Well, square root of 34 is 5.8 something, so that would be an answer of D, and that's not bad. The question is, can we get close to 6.0? Okay, so here I've abandoned sort of trying to strictly maximize, and I'm just taking some guesses. Okay, I know I can get AP squared being 34. Okay, let Q be 1, let P be 1, and that would give me an answer of D. And so if that's the best, great. If I can do better, okay, then the answer would be 6.0. But at least I've narrowed it down to 1 out of 2 possibilities. Either D or E is the answer, and that's usually good enough for a guess. I figure probably about the time that I've spent on this video and trying to figure it out, time probably would have been called. You only get an hour to do these contests. But So I would guess either D or E at this point, but let's continue on and see if we can find something a little bit better. Okay, so 6p plus 8q, could we maximize that in some way? I'm starting to think I've got the wrong setup, and that's because it's not the easiest thing to maximize a linear term like this with two variables, let alone to do that on a grade 10 contest. Sometimes the problem when I go back and do these older contests is I have trouble thinking like I used to when I didn't know as much. So like right now I'm thinking maybe I could throw some sort of arithmetic quadratic mean at this or something, but I think it's got to be a bit more basic. So what's going on here? Is my approach wrong? Now, if we zoom in here again, I go over P and up Q, and that's because P is, our point P is all the way down here, and we get a distance 4 up here and a distance 2 up here. And we were able to get that relationship with Q because we got a right angle here, we got 2 minus P here. Is it wrong to pick out P and Q? Should I start with just P or something and then derive my Q from there? No, because I'm going to get the same relationship again. Alright. What else could we do? What else would we have at a grade 10 level? So regardless of where I place A, if I don't name these guys for a second, could I do something? So A is always going to have a right angle here. And it's not like we can just choose any square. Right? There's a limit to what this square can look like and still fit in here with a right angle. Because it's going to have to be a right angle, and it's always going to have a hypotenuse of 2. And if you have all the right angles with the same with a fixed hypotenuse length, you form a semicircle. So the possible points for A lie on a semicircle here. Semicircle, we got a center, so it'll be 1s on either side. So the distance from the midpoint of WX to A is always 1. That can shift around a whole lot, though. But there's the semicircle connection, so instead of choosing P and Q from, admittedly, the sort of arbitrary X, I mean, it wasn't that arbitrary, it comes from P, what if we, making the connection that A has to sit on this particular semicircle, we measure our P and Q from this midpoint? Well, maybe even just measuring a P and Q isn't so good there. I mean, I can get to this midpoint. This midpoint is up by 4, and let's see, we go over by 2 to get to X, and then I guess we go over by another 1. Ooh, hello. Are you a 3, 4, 5 triangle? Well, you absolutely are. Okay, all right. So let's recap what I've just figured out. So we'll draw a picture a little nicer. And now, just because I have a 3, 4, 5 triangle doesn't mean this is going to necessarily work out, but I don't need the top of my square, really. So we get this midpoint here, coming across here, and we have all the possible places X can, or not X, A can be. Now we want to talk about AP. And if we had sort of the center of this circle, maybe we'd call it O. Well, center of the semicircle, I guess. But it's a circle of radius 1. So what can we do? We can talk about AO is 1. But more importantly, O to P is a 3, 4, 5 triangle. We go over by 3, 2, and then another 1 for the radius. And then up by the same 4 we had when we did 4 plus Q. And so that tells me that OP is 3 squared plus 4 squared square rooted, or 5. This is a very common right angle triangle that we should know. Okay. So what does that tell us about AP? Well, we've got 1, we've got 5. I suppose if we knew this angle here, we might be able to do cosine law. And that's trigonometry, so that's well within the capabilities of a grade 10. Actually, couldn't we just say that if A just swings into the right position so that AOP becomes a line, we'll get a distance of exactly 1 plus 5 or 6, and that was E, wasn't it? And if we can show that we can get E, we don't actually care what the maximum possible value is. Yeah, all these APs, unless if AOP is a line, well, if it's not a line, you will get a triangle, and the AP is going to have to be less than AO plus OP, which is 1 plus 5. These are fixed values. None of this PQ stuff. These are known quantities. But if AOP lies on a line, then we do have 1 and 5 here. So that would be a total of 6. So AP can be 6. And in fact, it can't be more than 6 because of this triangle inequality stuff. And 6 was an answer of E. That was a lot shorter. I'll just take a moment so I can spin this and make myself look like a teacher. Sometimes we do questions the wrong way at the very start. We get a plan of attack, and it completely is the wrong setup. If somebody can make that PQ thing that I was trying to do work, I would love for you to tell me a little bit about it in the comments. I really would. But I don't think it's going anywhere because you're going to have a square root somewhere at some point. It's really hard to maximize something like that. But this, I love this answer. It's geometric. We got a 3, 4, 5 triangle, and that's what really set me off there. And then with the semicircle and everything, and just, we don't know where it happens, but we know we can just swing that 1 so that it lines up with the OP, and we get an answer of 6, as clear as day. I love it. But, I wasted, 15 minutes maybe? Trying to do a method that just didn't work, and sometimes that happens. And you're not recording videos for the internet. You're actually doing these contests in real life, and you just kick yourself later. You really do. There's not a whole lot I can say for when that happens for you. The only thing you can do is try lots of techniques. Even if you've solved a problem, go back and try and do things different ways. And then you get a sense of, this technique might work if this is the situation. This might work if this is the situation. So that PQ, I abandoned that when I started realizing I got to do 6P plus 8Q, and I don't know how I'm going to maximize that thing. That's what made me think I need a new approach. I wish I'd noticed it sooner. Maybe I need to practice a bit more myself. But we don't know what will or will not work just by looking at a question unless we just start practicing everything. And it's good if you're starting to practice these Cayley contests. You're going to start learning when things work and when things don't. I started doing something that didn't work. Then I got something that did work. And you can be faster at recognizing, hey, what I'm writing, I don't think that's going to lead to a solution the more you practice these things. But I'm going to stop rambling now. I'm going to let you guys go. Thank you for watching. That was the 2007 Cayley, question number 25. And up next will be the 2007 Galois. Still grade 10 level, but it's a written contest. So, again, thank you for watching. And until next time, take care.